So guys, welcome to our YouTube channel, Tech Check. Here we will be talking about CAP theorem. CAP basically which stands for consistency, availability, and partition tolerance. What is CAP theorem? CAP is necessary for designing. CAP theorem is necessary for designing a distributed data systems. It allows us to choose between the two of the three CAP functionalities, which are consistency, availability, and partition tolerance. And we can make the trade-off between the three available functionalities based on the use case of our system. Why do we need CAP theorem? In distributed data system, it is highly dependent on the network systems, and there is a chance that our distributed system could be in a trap of network failures. In such case, we have to choose between consistency or availability. So that's why we need CAP theorem. Functionalities of CAP theorem. Consistency. Consistency basically means that everything should be well coordinated. Availability, the system should be always available. Partition tolerance, the system should be properly distributed. So we have three types of system, that is a CA system, CP system, and AP systems. Consistency. Consistency basically means that all data is well coordinated and properly synced. It ensures that all clients see same data, whether it be just after the read operation, just after the write operation, update operation, or delete operation. Whenever we perform a read operation, it should return the latest data to us. Availability. And this means the system is always readily available. For each request, we have a non-errored response, whether it be 3 nodes going down or 4. Even if a single node is up, we should have the data available to us. Partition tolerance. It is the most important, say, the functionality of CAP theorem, because having a distributed system, we need to have partition tolerance in it. We can sacrifice consistency or availability, but we cannot sacrifice partition tolerance. CP systems. CP systems mostly focuses on partition tolerance and consistency. These systems are not always available, but the data across them is always consistent. Let's take a real life example of a banking transaction. This is the best example I could take. Any banking transaction that is done from ATM, in person, online, or mobile banking has to have consistent data across all platforms, whether it be amount balance or whether it be a transaction. It has to be consistent. Let's take an example of a movie ticketing system. So whenever we need to book a ticket for a movie, we have to have no two people booking a same seat. So we have to have consistency across all systems, whether it be on the booking counter or on the mobile app. AP systems. AP system basically means it is more focused on availability and partition tolerance. It cannot be like that much consistent, but it has to be it could be consistent after a while, let's say after 5 minutes or 10 minutes or 10 seconds, depending on the functionalities we have. Real-time examples, YouTube and Facebook media uploads. Whenever we upload a video or a YouTube video on Facebook or YouTube, it may take a while to notify the subscribers or even reflect on other users' timeline. So here, availability is more important than consistency. Same example is for YouTube, Facebook likes and views. It may take a while to reflect when there are large number of views and likes on a video. WhatsApp. WhatsApp also uses this system for some of its functionalities, such as last seen. Whenever there's a low bandwidth, it concentrates more on the functionality such as calling, and I would say like messaging. So it is more of like an available system rather than consistent because it doesn't show proper last seen. CS system. These systems mostly focus on consistency and availability. They don't concentrate on partition tolerance. Although the partition tolerance as discussed behind on the previous slides, it is the most important functionality of any distributed system. So we rarely see it in real life. Therefore, I don't have any real-time examples for it too. Conclusion. For distributed system, it allows us to have a relatively high computing power and availability and scalability. It is essential for us to have an appropriate design for our system considering its consequences. So it becomes essential for us to understand how complex the system is, and then according to that, we can choose between the trade-offs, whether it has to be consistent, available, or partition tolerant, or a combination of them. So here we are with our first video. Do like, share, subscribe, and if you have any questions, just comment down below. We'll answer your questions. Thank you for being here.